Randomness is everywhere, filling our lives with surprises and changes. But are the events we experience truly random? Are flowers randomly grown? Is the encounter of one person with another random? Or is the probability of winning a prize random? What if I told you that randomness is not actually random? Firstly, let's clarify the meaning of random. According to Google, it signifies something odd, unusual, or unexpected. Moving on to randomness, its most critical feature is its unpredictability and uncertainty. We cannot accurately predict or ensure the exact outcome of an event. Moreover, the results of random events remain unaffected by preceding occurrences. According to the meaning of random, do you think if something happens twice in a row, is it random or fixed? You have the choice of yes and no, and the probability of drawing each is 50%. If you want to draw 2 yes in a row, the probability is 50% multiplied by 50%, which is 25%. This means that every 4 times, there will be one occurrence of 2 yes in a row. But do you think this is random or fixed? Before we begin, you can take a second to hit the like button and subscribe to give me your utmost support. Imagine I'm rolling a dice with numbers from 1 to 6, where the probability of getting each number is equal. I want to draw continuously for 6 times, so how many permutations will there be? Yeah, it's just 1 over 6 times 1 over 6, 6 times, which is 1 over 46,656. If I want to draw the same arrangement again, do we have a chance, and what is the probability? We just need to multiply by 1 over 46,656 one more time to find its probability. Just like the numbers in the picture, the probability of getting the same arrangement is very, very small. It's unlikely you'll draw the same arrangement again. However, even though the odds are extremely low, in randomness, miracles can still happen. Therefore, even in rare cases, we cannot rule out the possibility of the same arrangement occurring again. Suppose we haven't succeeded in the first 12 attempts, but we still have the opportunity for another 12 attempts. If we still haven't succeeded, we can try another 24 times, or even keep trying indefinitely, again, and again. We can keep rolling the dice until an infinite number of times, which is much more than you can imagine. If we roll the dice infinitely, do we still have a chance to get the same arrangement again? The probability of this happening is extremely small. The complete probability is 1 divided by 6 to the power of infinity, which is also 1 divided by infinity. His value will approach 0 infinitely, but it's important to note that it will never actually reach 0. Remember what I said earlier? A probability being extremely low doesn't prove that the event will not happen. So, it could still occur. If we keep throwing the dice indefinitely, then the probability to get the same arrangement would be the probability to get the same arrangement multiplied by the number of times we throw the dice. Which is 1 over infinity times infinity. According to the properties of mathematical limits, the result approaches 1. This indicates that as we throw the dice an infinite number of times, the probability of obtaining the same arrangement approaches 1, meaning it is almost certain to occur. It sounds amazing, right? It seems like this happens randomly, but in reality, it doesn't. All arrangements will occur again. Consider a scenario with a finite number of playing cards. Each time a card is drawn, it is returned to the deck before the next draw. If we were to draw cards an infinite number of times, eventually, we would repeat previous arrangements of cards. Although each draw may seem random, the finite number of cards guarantees that previous arrangements will recur in an infinite sequence of draws. Thus, even though situations may appear random on the surface, the outcomes have a degree of predictability and regularity. Therefore, we can say that random events are not entirely random, as they are influenced by certain conditions and limitations, resulting in a degree of repeatability in the final outcomes. However, achieving this requires certain conditions to be met, making it somewhat of an unrealistic ideal. The most important condition is the infinite repetition of events, with their probabilities remaining unchanged. So, what do you think about this idea? Do you think it's right or wrong? Feel free to share your thoughts and leave a comment below. At the end of the video, don't forget to subscribe and like my channel. I'll be sharing more interesting mathematical ideas.